At the start of the topic, we asked the question, what would happen if you spilled a pile of nails or pins? How could you pick them up easily? And the answer you came up with was using a magnet. And so, there we go. Now, we also asked, what was the disadvantage of using a magnet? Well, they stick to the magnet and you then have to pick them off. And whereas that's not too difficult with this magnet, if you had a strong magnet, that will cause a bit of difficulty. Is there something else we can do? So what I have here is an electromagnet. Normally, it is not magnetic. You can see the nails do not stick to it. But if I turn on the power, it becomes magnetized. And the advantage of this is I can turn off the power and it loses its magnetism. It's very easy to make an electromagnet. All you need is a coil of wire and a core to wrap it around. In this case, it's a sort of horseshoe shaped, but as we'll see, it can be something very different. We've already seen how a compass will line itself up with the magnetic field of a bar magnet. So it'll point towards the south or point away from the north. And we can use a compass then to identify whether something is or not magnetic. A bit of wire is not magnetic. But if we put current through the wire, you saw that the needle moved when the wire's nearby. So whenever current flows through a conductor, it produces a magnetic field. And we're going to see what can we do to change the direction of that field and change the strength of that field. Okay, on page 12 of your notes, it tells you to get a pencil and wrap a bit of wire about 20 times around it. And we can see here that the plotting compasses around it are all pointing in this direction. And then it says, turn the current on and notice what happens. And you should see that the plotting compasses all moved a little bit. Not a huge amount, but you can see that as I move the coil of wire around, they do move. This coil of wire is known as a solenoid. Now, because the compasses move, it has a bit of magnetism, but not a great deal. If I got some paper clips, let's see, well, is it able to pick up any paper clips? No, it's not able to pick up any at all. So it's not a very strong magnet. What I'm going to do is I'm going to replace the pencil with a nail and see what happens. The pencil goes out and the nail goes in. The nail's made of iron. When I turn that on, you can see that the plotting compasses have moved quite a bit more significantly. Furthermore, you should be able to see that some of these paper clips are now sticking to the coil. In fact, they're sticking to the end of the nail. And if I turn the power off, they start to fall down. They don't fall down immediately, but most of them have fallen off. So by changing the core of the coil from a pencil made of wood and graphite to an iron nail, we seem to have made the magnetic field produced by that coil an awful lot stronger. So how many paper clips could we pick up? We couldn't pick up any with the pencil, but with the nail as the core, that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Couldn't pick those 4 up. So you can record that at the bottom of the page, on page 12. Hopefully you can remember that a compass will point towards the south end of a magnet, the south pole. Here you can see it's pointing away from the north and towards the south. Let's see what happens with our electromagnet. So I turn the magnet on and the head of the nail, the red end of the compass, is pointing towards it. That means that the head of the nail is a south, and the tip of the nail is a north. What happens if I change the direction of current? To do that, I'm going to swap the cables for the power supply. So now the current's flowing in the opposite direction. The head of the nail previously was a south. Now you see the compass is turned around. The head of the nail is now north, and the point is a south. So we can see that by changing the direction of current, we can change the direction of the magnetic field and change the polarity of the electromagnet.